9 part of the session where I will tell you how to deploy Spring Boot application in Minikube cluster and using GitHub Action. In this session, we will be deploying about the second job, deploy. In the previous session, we had already discussed about the first job. We will be here building Docker image. First, we will build the Docker image. Then we will be scanning the Docker image using Trivy. Then after scanning, if everything is okay, then we will be pushing the Docker image into the ECR. And then we will scan the YAML files by using Terrascan and deploy the applications to the Minikube. So let's quickly go to the pipeline and see the step-by-step explanation for deploy job. So if I go to the Actions tab and click on the Spring Boot Application CI/CD and go to the workflow here quickly. So earlier we have seen that this job, build job, we have seen that there are many steps assigned to it where we are installing the JDK clean, doing Gradle clean and build to build the image packages, and then we are then we are doing the SonarQube part, and so we are doing code scan analysis using SonarQube. So this was all for the first part of the job. In the second part, deploy, the workflow starts with checking out the GitHub repository by using the YDC approach, allowing the workflow to assume an IAM role. Then it is what it is doing is it is connecting to the GitHub Action to AWS using the YDC approach and allowing the workflow to assume an IAM role to access the AWS resources. Basically, it is accepting the credentials, the token that is sent from the AWS, and activating the credentials. Then what it is doing is that it is downloading the artifacts which are built previously. So in the previous step, what we have done is like we have uploaded the build directory. Basically, this build directory contains that jar file which we need in our next step. So here we have some Docker files, some build files which we basically need to deploy our application. So that's why we are uploading it into the previous job, and here we are uploading it, and here we are downloading the artifacts. So here is the path where we are, this is the artifact name, and here is the path where it is getting downloaded. So then and displays the structure. So here it displays the structure of the downloaded files of the artifact in this script. Then what it is doing, after that the workflow logs into the Amazon ECR and uses the AWS CLI command to build. This is the registry that we are getting from here. We are automatically fetching the registry by using this step command. So this is the syntax here, steps, because these are running in steps. Then login ECR, which is the ID present here, and this is the output section, and this is the registry. So we are getting the registry here of the ECR. First we are printing what is the ECR registry, then we are building the image. So this image tag is, we have defined the variable here, image tag, which is latest. You can provide another variable name, maybe a build tag or something, which dynamically changes. For our demo, we have taken the latest part. So here what we are doing, it is building an image of Spring Boot with an image tag latest. The Docker file is present here in the current directory, that's why it is a dot. Then we are tagging the Spring Boot application with our ECR repository registry name. Then we are pushing into the registry. Okay. So after this, what we are doing is like we are tagging and pushing the Docker images to ECR. So we are tagging and pushing those images to the ECR repository. Then what we are doing is like we have then we are getting the public IP of the GitHub hosted runner, which is the Ubuntu machine here, because again we have to whitelist our GitHub Actions IP address to our EC2 instance that we have created into by using the Terraform. So here we are doing it. We are getting the security ID of the EC2 instance from here. And in this step, what we are doing is like we are giving 22 port here, and giving and whitelisting our GitHub runner IP address here, and we are even setting out the output at EC2 IP so that we can use this EC2 IP here. Then what we are doing first, here we were whitelisting the IP address of the GitHub Actions here, and now what we are doing is like we are taking out the public IP address of the EC2 instance created by Terraform, and then we are creating an output variable EC2 IP so that this variable can be used in the other steps also. So then after that, this copy YAML file via SSH. So there is a YAML file. If I open another tab and show you, there is a Spring Boot application YAML file. Here, this is the YAML file. So basically, by using this action, we are giving the host name. This is the host name of the EC2 instance created by Terraform. This is the username of the EC2 instance, and this is the private key. So we are just taking the YAML file from the GitHub action and putting it into the target machine. Then what we are doing is like in the next step, pulling the ECR image and then scanning the Docker images using Trivy and uploading the Trivy reports to S3 bucket. So here by using this Appleboy SSH action, we have logged into that EC2 instance created by Terraform. Then we are doing ls-na to check all the contents which are present in the current directory. Then we are updating all the packages and all those. Then we are installing the AWS CLI. Then we are authenticating AWS ECR and doing Docker login. Then what we are doing is that we are Docker pulling the image that is created. Then we are checking the Docker images. And then what we are doing is like, since what we need to do is like we have to see the Docker image, like we have to scan the images using Trivy. So this is the command. It is scanning the images using Trivy, and it is copying the Trivy image scanning report to this S3 bucket. So if I quickly go into this S3 bucket and show you, so this is the if I go in this bucket only, right, there is two directories. One is Terrascan reports and one is Trivy reports. So if I go inside the Trivy reports, right, so here you can see what all things it is scanning. You are able to see that it is low, medium, zero. So there is only one critical vulnerability. Apart from that, everything is okay. The image is fine. So we can directly use that. So if I go here and check, so it is successfully deploying the Trivy scan report into the S3 bucket. And the last step is then by using then again it is logging into the EC2 instance and doing Terrascan. In this step, it is scanning this Spring Boot application that I showed you, scanning this whether it is okay or not, and then it is scanning and showing this, resulting this one. You are able to see these are the violations or some like low violations are present, what are high, and it is showing what is the description of this error that it is getting. So you can enable it, you can resolve this by seeing these. And then what we are doing, we are copying the same we are creating the Terrascan report in the EC2 instance and then copying that Terrascan report into the EC2 instance. So, and then when everything is okay, then we are applying the Spring Boot application. So let's go to the slide 2 and check the Docker file steps that we have applied. So this is a Docker file that creates an image for a Java application. The image is based on the official OpenJDK 17 runtime, which is a lighter version of the official JDK, which is based on Alpine Linux. So from OpenJDK 17 JDK Alpine means this instruction is basically setting the base image for the container to be OpenJDK 17 on Alpine Linux. Then the second command is like it sets the working directory for the container to be /app. Then the third command, what it is doing is copy build the snapshot jar. So this copies the application jar file name as demo 0.01 snapshot.jar from the host machine's build its directory to the container apps directory, and it is renaming it to app.jar. Then this expose.8080, it tells the Docker that the container will listen on port 8080, and in the CMD the instruction runs the command java jar when the container is launched. So this command runs the application that is packed in the app.jar file. So when you build this image and run the container, the application will be running on port 8080 and can be accessed via localhost 8080 or the IP of the container if you are using in a different environment. So let's go to the Kubernetes deployment and service. So this is a YAML file. So the deployment file defines a single replica of a container which runs the latest version of the Spring Boot application pulled from the ECR Elastic ECR in the US Eastern region. The container is labeled with app demo. Container is labeled with app demo, and the deployment and the service have the same name, which is the demo. Okay. The service defines a cluster IP service that exposes the port on 8080 on the cluster and directs traffic to the port 8080. So this allows other ports within the same cluster to access the application using service DNS or the IP address. So the app version V1, it is the version of the Kubernetes API deployment used. This is the type of the resource. So this is the type of the resource which is deployment. This is the metadata which contains information about the deployment such as names and label, when name is demo and app is 0. Then spec, what is doing, contains the specification of the deployment with a replica of 1 and match labels with app demo. So it is matching with this name demo. Okay. And this is the template. So template defines the pod template that is used to create new pods when the deployment scales up or down. So the service, so here in the service API version is the version of the Kubernetes API. The kind is the type of resource. Then the metadata contains information about the service and its name and the labels. When spec, what it does, it contains the specification of the service where ports lists the ports that the service should expose, and the port here, this port on the protocol which is used, and the target port on the port that the service should route to, and the selector, what it is used to specify the labels that are defined, the ports that belong to the service. So this app for the labels. So now you need to so if I go directly here, so here you can see that when I did kubectl get all, you are able to see that everything, that pod is running. You can see all the things, all the resources, like pod is running, the deployment is running, one replica set as you know, and the service is running, which is demo service. So we have port forwarding, since it is a cluster IP, we have port forwarding this IP to 8080 port, since this is running on Minikube. So if I go to the next step and show you, if I do curl localhost 8080 actuator health, you can see that the status is up. And you can see that if you are doing curl 8080 actuator GQ, you can see all the contents and links what are shown. So here it is showing that the application is up and the status is voted. So this is all for the 9 part of the session. I guess you have got the whole idea. Thank you very much.